So now we will talk about each connection diagram. So we have an IR sensor 3-pin. So it will connect, one will be connected to the 5-volt input, the second one will be ground, and the third one will be the attached as the digital IO pin 0. So that is the general diagram for the connections, and now we will shift on to the LabVIEW program to see how we acquire data, sensors data, or how it works by using LabVIEW. So after making connections with my-DAQ and IR sensor, as I have shown earlier, we will shift on to our LabVIEW program. So here I have opened a block diagram, and now we will start our programming, how we acquire some sensors data into LabVIEW. And there we just right click on our block diagram, and there we have a measurement palette, and there we have an my-DAQ device, all of the blocks that are used for the data acquisition by using my-DAQ. So here are the simple functions that we can use single-handedly, like it means we can just attach them by in a sequence to do our function that we want. But there is some other plug and play style that is DAQ assistant that we can use in here for the data acquisition. So DAQ assistant allows you to set all the things within just one window, instead of just fetching all of the blocks one by one and placing on the block diagram and then just attaching. We can change it, we can just make all of the things for the data acquisition setup or the configuration within just one window. So here we have some acquiring signals or generate signals. So it means that it acts like input or output, either it could be digital or analog. So if we go on to the acquired signals, here we have again analog input, a counter input, or a digital input. Since we are dealing with IR sensor, so we just want to detect something, it comes in front of it, or it detects something or not. So we will just go on to the digital input. So in digital input we have line input or port input. So if we are dealing some sensors that have analog or acquiring some sensors data, then we will go to analog input, and there we have a multiple options, like for plug and play style. If we are using temperature sensor, then it has already a thermocouple and VX sensor or RTDs and etc. Or we can just even measure a voltage, basically, since we have already talked that my-DAQ is a general purpose device. But since again we are dealing with an IR sensor, so we will just go to digital input, and here these are the two options, line input and port input. Port input basically means that at which port you have just connected your my-DAQ, and the line input means we are having at which point or the digital input pin you have connected your sensor. Since we have just connected, as we have shown, that we have connected our IR sensor at the port 0, so I'll just select the port 0, line 0, and then finish it. And once we finish, another window pops up that shows that if something has connected on it or not. We can just set the samples, like one sample on demand, or one sample at the timed, n number of samples, or continuous samples. We can, if we set continuous samples, we can also change its samples to read like 100 samples per second, and this the frequency of the sampling rate is 1 kilohertz. But right now we will just go on to the one sample and then press OK. So it will take some time to build all of the configuration in it. So here we have, if I just right click on the terminal of this DAQ assistant, then I'll get this window, and here I can create an indicator basically. So if I create an indicator, an array of data is created. If I double click on this icon, then here I have almost 8 LEDs that are shown in here. So it means that the line input shows me all of the digital IO pins that are available on my-DAQ. Since we didn't need all of the digital I/O pins, so what we can do is we will just delete this function or the indicator in here that is shown us in the form of data, and we can remove this broken wire, remove loose ends, and then again right click and then go to array. And here we have a function of index array. Index array means you can choose any of the index, which means 0, 1, 2, 3 or so on purposely. So if I connect that in here, and now I can just give it an index of 0, which means that it starts from 0, so I will get only one LED instead of getting all of the elements in here. Since we have set our my-DAQ as one sample on demand, so it means that if I run my program, this will execute only for once. So if I run my program here, this will execute for once and then just stop. So to make it continuous running, then we use again a loop within the LabVIEW. So here we have while loop. So I will just drag that in, and all of the functions are inside of the while loop, but it is giving me an error right now, if you notice, which means that we have to set a condition when this loop will stop. Right now the problem is that, so I will just simply create a control and go on to my front panel and place the control of the stop at the proper position. I can just even increase its size so that it will be more clearly visible to us. And this is the element we have on our front panel, as that shows either something has detected or not. So now if I go onto my block diagram, if I just create an indicator in here and numeric and just place that in here and run my program, it shows that this numeric shows that this many times the loop has been iterated. So it means that it is acquiring data with this much speed. So now we will just put a delay so that we do not excessively use our memory of computer. So I'll just delete this. Before deleting this out, I'll just place a timing function, or let's just say the delay function, so that we can control our data acquisition speed by controlling the speed of iteration of the loop. So if I can create a constant in here, this 10 milliseconds represents that the loop will delay by the distance of 10 milliseconds basically. So now if I run my program, the speed has been slowed down, but it is up to right now 10 milliseconds right now. If I just increase a little bit more, like 100, then it will slow down a little bit more. So if I run my program, as you can see right now, the data acquisition speed is right now very much controlled, and this is the right and appropriate time, the time period to acquire the data, or the frequency that has been set right now. So again, we will just go on to our block diagram, delete this numeric since we didn't know. This is all was to just show that how the data acquisition works. We need to set the frequency, we need to set the time period of the data acquisition, otherwise it will be create some bogus or use excessive memory of the computer. So now we'll just delete this broken wire, and now we'll just run our program to see how it works. If I run my program right now, I see that my LED is already turned on. So if I just bring something in front of it, it shows that the LED goes out, which means that the LED turns off. So it means that it is working oppositely right now that we need. So we need that if something comes in front of it, LED should turn on and it show that something has come in the range of IR sensor. So what we do is we will just go on to our block diagram again, and we will just invert this input. So we will just go to our Boolean palette, and there we will find out the NOT gate. So the NOT gate, it works accordingly that we need. it means that if we just if the input is high, then it will change it to low. Otherwise, if it is already low, yeah, it will turn into high. Since we were getting it as in high position before, so now it will turn it to low position for the beginning. We will just go on to the Boolean properties as well and show at which state it is turned on and off. So I will show the Boolean text as well. So now it will show us turned on or off. Now if I run my program, it is turned off, and if I bring something in front of my IR sensor, now it shows that the IR sensor has detected something. We can increase its functionality by just increasing some of the programming in it. We can just show a string function that will show us whether it has something detected or not. So what we will do is I will use the string indicator by just going on to our front panel. Here I will get a string indicator, place that in here. This will convey us the message that if something has detected or not. So we'll just go again to our block diagram, and here I will use a comparison function in which I will use select function. So I will just connect the output of my element or the NOT gate, which is just giving us the result whether it has detected something or not in the form of the boolean. We will change this result into some written form, like it will tell us it has detected something or not. So now it has two cases, whether it is true or false, like the LED turn on or off. So we'll just use a string function or a return function that will tell us whether it has detected something or not. And in the true function we will say object detected. And similarly we will make a copy of it by just pressing Ctrl and left click and drag. And then we have made the copy of our first constant, and here we will change our text and change it to not detected. Now we'll just connect the output with our false condition of the case selector, and then we will just give the output with an indicator. So now if I run the program, it shows that nothing has detected, and if I just bring something in front of my IR sensor, it says that the object is detected. We can increase its functionality and change it to RPM measurement. That requires a little bit more programming, and I hope we will do that in some other sessions.